Good morning. It's always nice to come to Korea. 今日はいい天気ですね。とっても面白い。長くね。今日はTokyoは What language was that? That was Japanese. I speak Japanese because I lived in Japan for 2 years. But Japanese and Korean are different languages. Safety-critical software is similar to regular software, but it's different. In Korea, we have dark hair and we speak with very interesting letters, similar to Japan, but it's not the same. This speech is about safety-critical software. Let me ask you, how many of you program sometimes in the C language? Yes, many people. Now watch. How many of you never had a pointer error? Oh, everybody, yes. We all have pointer errors. In regular software, Microsoft, no problem. Many pointer errors. Reboot. But in safety-critical software, people can die, okay? Some years ago, a Boeing airplane was flying with 223 people. Suddenly, mechanical problem, electrical problem, software anomaly, defect. Thrust reverser comes down. The pilot cannot raise thrust reverser because software logic says only if weight on wheels can thrust reverser come down or come up. Everybody died. 223 dead people. That is safety-critical software, okay? Japanese is not Korean. Safety-critical is not regular software. I want to talk to you today about the top mistakes. Maybe I made them all, okay? Hopefully you do not make these mistakes. So let's look. Now, safety-critical may seem subjective, but your software cannot be. It must be deterministic. So, we will discuss today requirements quiz, safety-critical requirements, some examples, and the top mistakes, because safety is important. So this is a little bit about a fusion. We've worked on many airplanes. I teach many people safety-critical software for aviation, automotive, medical device. I think I worked on every airplane flying the last 30 years. Is anybody in this room a pilot? Not so common. I'm a pilot. Not a good pilot, but okay, I'm not dead yet. So, we work on many programs. Let's have a quiz. I know in Korea, I come here many times. I work with many companies. I think you're very smart, really. You like tests. It's an easy test, true, false. Let's see the answers. In 30 minutes, I give you the answers. But think, what is the answer? Number one, on most projects, most software requirements are about safety. True or false? Safety critical. Number two, safety critical requirement development must follow the waterfall. We have standards, 26262, 61508, DO-178, number, blah, blah, blah. They all are similar. You know the waterfall. Watch. Requirements. Design. Code. Integration. That's the waterfall. Just one problem. Water goes down. Easy. Does not come up. And projects change. Always changing. What do you call a software project with no changes? Impossible and dead, right? All successful projects have changes. Must we follow the waterfall? The best way to assess safety critical requirements is by testing. True, false. Number 4, safety critical standards provide great information on making safety critical requirements. Number 5, most safety critical defects are due to bugs and manufacturing defects. 5 questions. True, false. Better odds than Las Vegas, right? We'll provide the answer soon. So, what is a software requirement? Measurable software processing that's necessary. We can assess it. Safety critical requirement. A necessary aspect within a system whose anomalous, bad behavior would affect safety. So, safety critical covers many domains. When you come this morning, train, car, medical, airplane, it's all safety critical. The software size and complexity you saw from our previous good speakers, it's always increasing exponentially. A Boeing aircraft today has 10 million lines of code. Joint Strike Fighter, F-35, 20 million. A Mercedes car, 30 million. Okay? It's always growing. Yesterday's non-safety is today's safety. Even your cell phone is safety critical. Help! I'm at the conference. There's a fire. Oh, reboot. You see? Everything is safety critical. So requirements must guide development, identify faults, and use a scientific left brain, right brain approach. What is that? Well, experts say most problems come from requirements. Requirements are very important. Safety critical requirements must include safety, but also functional. What does it do? How fast? The performance, the timing, the integration. Most requirements are incomplete. The number one cause of defects and dead people truly is requirements. We need to identify requirements, specify, verify, and manage those requirements. So let's look. All of us, we all want to be healthy, right? How many of you exercise every day? How many of you only eat healthy food? What is health? It's food, exercise, flexibility, heart, muscles, sleeping, diet, peace, no crime. I live in Los Angeles. I know that. So health is everything. Same with safety critical health. For software systems, there's many factors for health. For example, these are goals. They're not requirements. Look, the system must be safe. Of course. Serious accidents cannot occur. Really? What is the probability of software error? 1%? 3.24%? No. The probability of software error is 1. Software can and will fail. The question, can we detect it? Can we mitigate it? What do we do? So I work for Boeing and Airbus and all the big companies. People ask me, who makes the best airplane, Boeing or Airbus? Ooh, I hate that question, especially with the French guys in the room. Oh, let's see, where am I? Today I'm in France. I must say Airbus. But I'm honest. I'm an engineer, not a politician. My name is not Clinton or Trump. I tell the truth, okay? Boeing and Airbus make different airplanes. Which one is safer? I know the answer. Do you want the answer? Okay, are you sitting down? Yes, of course. You're listening to me. The answer, Boeing or Airbus, safer? I have a question for you. How good is the pilot? Oh, because the answer is like Porsche and Cadillac. Porsche takes an expert driver, not me. I'm a bad driver. Good pilot, bad driver. I think the Cadillac is safer. The Cadillac makes all the decisions for me. The software is more powerful in the Cadillac. Who makes Cadillac airplanes? Airbus. Ooh. The computers make many decisions. Who makes better airplanes with a good pilot? Boeing. Okay? Safer airplane if you have a good pilot. Ooh. So usually Airbus is more safe, except when it's not. Weak pilot. So think, can you guarantee the pilot? Interesting question. With safety critical software, those are goals. How do we make safer systems? A major problem is specifying safe requirements. Look at this. The XYZ system shall have specified faults. The system shall do X when Y. The system has fewer defects over 20,000 hours. The system shall detect blah, blah, blah. Those are specific, generalized requirements. That's the starting point. Now, how do we make safer software? And what are the issues? What are the top mistakes? So, number one, remember our goal. Our goal is to divide this room. You, congratulations. This half, you're going to Hawaii. Very nice. This half, no Hawaii. you're going to Greenland. Greenland is not green. It's white. Always snow and ice. So, I have requirements. I give the same requirement to Hawaii, the same requirement to Greenland. Don't worry, you have much time to program. There's nothing else to do in Greenland. But you come back in 1 year and you have equivalent systems. No questions, no internet, no Google, just read my requirements. Is there enough detail, consistency, that Greenland and Hawaii can make the same product? That's the goal. So, I need continual reviews. I review the requirements with different people in smaller groups. I increase with more thorough reviews. Remember, it's better to prevent a mistake than fix a mistake. In safety critical, if we don't fix it, people can die. Number 2, we must have a checklist. Everything has a checklist. Even the pilot has a checklist. Ready? All airplanes have 2 pilots. The doer and reviewer, co-pilot. Let's watch. I'm the pilot. Prepare for landing. Prepare for landing. Landing gear down. Landing gear down. Does the pilot know the checklist? Yes. Can the pilot use his memory? No. All pilots must use a written checklist, just like that. Number 3, number 7, number 19, check, check, check. Flaps set 18 degrees? No, this is a 787. The flaps should be 37 degrees. Oh, whoops, 37. Check, check, check. So use detailed checklists for those requirements. Then, review the requirements in context with the code. The purpose of the code review is not, can I make better code? No. The purpose of the code review, does the code meet the requirements? So the requirements are the number 1 input. Use them. We must have traceability. I must prove every requirement is implemented. Every line of code is there for a reason. No dead code. And every requirement, every line of code has tests. So I prove top to bottom and bottom to top during the code review. Review everything at once. Now, transition criteria. Microsoft does not do this. That's okay. Microsoft does not make safety critical software. Safety critical software, we need transitions. This is the transition. Let's look. The code review has 6 inputs: code, requirements, trace, design, coding standard, and the checklist. The review completes the checklist, finds defects. This is the transition. The review must prove all inputs used. In Korea, in Europe, in America, our law Our law says we are innocent until proven guilty, right? How many of you have been arrested? No, don't answer. But if you're arrested, you're innocent until proven guilty. But not here. In safety critical, we are guilty, guilty, guilty. You must prove innocence. Prove you followed these transitions. This I call the green snake. It's my opinion, okay? It's not formally required. But this is my company's opinion. We have plans based on safety. We assess the plans, and then we perform. Can we use waterfall? Yes. Should we consider agile? Yes. We must be efficient. But we must prove every arrow. There are 22 arrows. We must prove all the arrows with evidence. Remember, guilty until proven innocent. Now, number 7. Number 7 is interesting. We must apply safety before development. I must think, what are the potential faults? We had the good example of the braking system 30 minutes ago. What could potentially fail? For every failure, what happens? How do we detect that failure? If we cannot detect it, how do we mitigate it? Do I need redundancy? Do I need health monitoring? I do fault tree analysis, FMEA, and it's a continual process, okay? Continual throughout the project. So, I have feedback loops. Safety, system, software, hardware. But anything that could affect safety, I must ask, can it affect the safety analysis? Remember, Boeing, weight on wheels, air lauda, 223 dead people, okay? We did not do that. Today, we must prove we did that. The continuous safety feedback loop. Now, independence. Independence is about the verification process, okay? For safety critical systems, I must have 3 people. Number 1, quality assurance. Quality assurance has 2 jobs: approve the processes and then assess the engineers. Medical, nuclear, transportation, airplanes, cars. Processes, assess. Then I need 2 people. One does the work. They're called a doer. They do work. What is work? Requirements, design, code, test. Then I have a reviewer. What do they review? Requirements, design, code, test. I have a great idea. I'm making an automobile. I want redundant brake control. But it's automotive. I want to reduce cost. I have a good idea. Let's put both control lines in the same tube. Do I have redundancy? No. One single fault breaks redundancy. Okay? So independence is also functional independence. I must consider functional independence, engineering independence. Okay? As criticality level increases, more independence. If I have a low criticality system, do I need full independence? No. Should I use full independence? Yes, because today's low criticality might be next year's high criticality. Save money, don't do it over. What's the minimum number of people for ASIL C? That's autonomous driving, okay? We have 4 people, the certifier, QA, the doer, and the reviewer. In that case, 4 people. Now, mistake number 9. 2 problems. Number 1, you have fantastic plans. They're great plans. Just one problem. You don't follow them, right? We call those beautiful plans. They're so beautiful, they are never used. The other problem, they're not complete, okay? You must have the same people follow the same plans for many years. Can you recreate the same software? The plans must be completed at the beginning. Do you remember the snake? Let's look at the green snake. Remember? Where were the plans? The plans are the top. This is the planning stage. The top is planning. The bottom is implementation. Okay? The plans must be complete. Is this a safe building? It looks safe. We're all alive. But is this building safe? Can I determine the safety of this building after this building is completed? No. I must assess during the construction. Do I have cement in the foundation? How strong behind the walls? White box. What's inside the walls? I must audit those plans from the beginning. And finally, plans must be approved by quality assurance, but not too detailed. How many of you have seen 500-page plans? I hate them. Why? Nobody reads them. Too much detail, okay? It's like a recipe. Please make bread. Use a 22-centimeter glass bowl. Stir the bread 17 times clockwise. Really? Too much detail. It's what you do, not the how. What, not all the how. Now, testing. After that Boeing crash, the big crash, 223 dead people, that company hired my company to fix the software. The first thing we did, we spent $2 million making a new system, a test system. We made the test system before we made the software. Then, every day, as we made the software, at 5 o'clock in the afternoon, 1700, push the button, start the tests. Every day, we tested the software, continuously. For safety critical, most defects happen from side effects, interactions, changes that caused bugs. 30% of all bug fixes cause more bugs. Okay? You know that. I know that. We all know that. The best testing is automated testing. If I automate all the testing, there is no regression analysis. Okay? I just retest everything. Now, most people write the test cases after the software. It seems normal. Let's look. This is a traditional software engineering. What does this look like? Water, water, water. The waterfall. Right? But look, the tests are written after the software is developed. Then we have the tests. It seems normal. It's the water. But look, this is a better test. Write the test cases after the requirements. We must review the requirements, right? What's the best requirement review? Write the test cases. What's the number one cause of software defects? Assumptions. Okay? How many of you read the book Mythical Man Month? Anybody? Some of you? Yeah, nice. It's a great book. 1 hour, $20, cheap and small. I like that book. The number one cause of defects is assumptions. If we cannot write test cases, ask, how can you write the software code? Only one way, assumptions. So write the test cases to improve the requirements before you make the design. Do it this way. It saves much money. Okay, you ready for the answers? Number one, most requirements are safety? No. Most requirements are functional. Number two, requirements must follow the waterfall. No. The standards follow the waterfall because it's easy to document, but it's very expensive, much time. So instead, use an efficient combination. Use the V model or an agile spiral approach instead. Number three, the best way to assess requirements is by testing? No. You want to know something amazing? Shall I talk about Hillary Clinton or Donald Trump? No. I don't know anything about politics, but I do know software. Let me tell you something amazing. Testing does not improve software. Ooh. Testing does not improve software. If testing improved, I have a great idea. Let's buy a 30-year-old Ford car. Not so good. 30-year-old Ford car, and test it. What happens? I get a new Mercedes. Really? No. Testing does not improve quality. Testing assesses quality. Testing determines quality with a feedback loop to improve requirements. Then I get a Mercedes or a Kia or a Hyundai, right? Number four, the standards provide clear guidance for assessing. No, they don't. Who provides guidance? You do when you write the requirement standard. Remember the transition criteria? Oh, yes. All the reviews consider the requirements. Iceland, Hawaii, consistent, detailed requirements. Number 5, most bugs are due to defects and manufacturing. No, most bugs are due to weak requirements. Okay? So there you have it. And we're done. If you'd like some more information, you can get free white papers. If you download them, there's a sign that says you must pay, but don't. Just say you attended the SPRi conference. You can get them all for free, I promise. I sent a letter to the company. Anybody this week from SPRi who requests these gets them free. So just request for more information. Now, we are 1 minute ahead of schedule. Right? I finished 1 minute early. What do you call a safety critical project that finishes 1 minute ahead of schedule? Impossible, but good luck. Thank you.
Thank you for your presentation. Thank you so much.